I'll just round out this point of Wiggles, and then you can go ahead, Chris. So what Wiggles is saying is, if the Earth is a sphere, then it will have a radius of thus, and then he has a radius of thus in his presupposed calculator. Therefore, the Earth is a sphere. So when we started off this conversation, I pointed out that it would be an affirming the consequent fallacy, and he's basically provided that if Earth a sphere, then X amount of geometry will be observed. X amount of geometry is observed, therefore R. So he's got R already in the calculation that he's going to be comparing to prove R. You've already got R in this calculation. So if you're trying to prove Earth a sphere, how come you've already got Earth as a sphere in the calculation?
Well, Nathan, what I said, I thought I made it kind of clear. I'm not proving that Earth is a sphere. I'm just proving it's not flat. That's really all I care about.
You're not proving it's not flat. How are you proving it's not flat? Does your calculation include the actual optics that will be used to compare when you compare your model to reality?
Well, the way that we do, it's just like really dead simple almost. It's like this is like, I probably shared this image before. It's just like the ocean getting in the way of distant objects.
Yeah, sorry, my question again, just so it's repeated. In your calculation for what you have already declared is simply geometry, have you accounted for optics?
So what do you mean by accounting for optics?
What are optics, Wiggles? Are we using optics for these pictures?
Well, they're pictures like we take.
So that would be a yes then, would it?
Right?
Just a simple yes or no. Are we using optics for these pictures? Yes or no?
That's sort of a weird question. Like
it's a yes or no question. Yes or no? Were these optical representations of reality using optics to attain them? Yes or no? I'd have thought the answer was obvious. Clearly Wiggles thinks it's a trick question.
Well, I mean, the pictures were taken by a camera.
So would that be a yes, Nathan? These absolutely utilise optics.
I guess so, sure.
Yes, excellent. Now show me where that's accounted for in your calculator, please.
Well, the calculator is just...
Put your calculator on. Put it on screen now.
Okay.
Where is the optics accounted for? Namely, the Rayleigh criterion. Where is it?
No, what the curve calculation, all it does is just calculate the height of the height of the obstruction of the object.
So let me get it straight. You're going to compare something that's only dealing with geometry with something that's optical in nature. Well, no, Wiggles, that's totally incorrect. That would mean that you would ignore the very aspect of optics that's been used to acquire the thing you're going to compare to a geometric-only calculation. Well, that's not a fair comparison, is it, Wiggles?
Well, so Nathan, what all I'm doing, right, is like the y. I'm just letting y be the height of the obstruction of the object, right?
Sorry, you've just shown us that you'll compare it to optical based information, and I've asked you to show me, you're yet to do it, where optics are taken into account, and you've said it's geometry only, therefore not comparable to the pictures you've shown. I don't know why you've shown them. I want to get to the end of this live show with you understanding that your calculator isn't calculating what you're seeing, because what you're seeing takes into account optics and you haven't accounted for that. So why are these being compared to your calculator, Wiggles?
Well, Nathan, if I, like, say I got a fence in my backyard, and I'm, I don't know, calculating the height of the post, and then, like, I got another post, like, say, in the middle of my backyard, and I stand behind the post. I'm just trying to calculate what the height of the post I can see or what the height of the post I can't see is based on, like, what's blocked by the first post. Like, that's just a geometry problem. It's like, this is a classic problem that you might be given in, like, high school, like, calculate the height of the flagpole given that this angle is this shadow is this. It's just that type of problem.
Sorry, Wiggles, where in your calculation does it factor in the optical nature of the pictures you are comparing the calculation to? Does it account for optics? You've already told us it doesn't. So it's not comparing the actual information you're using, you're only using geometry, therefore excluding things like perspective, which is absolutely there in the pictures you're using.
Okay, so Nathan, maybe it'll be useful. Actually, I thought like everyone was kind of familiar with the high school geometry, but I'll just go through an example of it, I guess. Like, so like we have a flag that's this
Sorry,
high.
why are you still pressing on without acknowledging a word I've said?
Well, I'm
Do
trying
you
to
have
get.
Asperger's?
Sorry,
Wiggles,
Chris,
do you have
say again?
Asperger's?
No, as what I do is I listen to the thing Nathan says. It's sort of like I think he's confused a little bit, so I try to go through an example that will try to clarify it for everyone. That's the way
There's
I
no
approach
clarity
it.
needed. There's no clarity required. What's on screen now, this picture that I've got on screen, includes perspective. It also includes diffraction limit based on the aperture of the camera. Now, those things which are absolutely present in this picture, i.e. things that are in the near foreground, like this tree, for example, can seem like they take up half the frame. Yeah? Now, I'm not going to give you a feet and inches measurement. I'm going to say by virtue of perspective, this tree literally takes up half of the frame. Whereas over here on this mountain, this tree takes up 16 pixels. So it's the same size tree in feet and inches, but your calculation doesn't take that into effect. In other words, the things that are in the near foreground will have the same measurement attributed to them as the things in the in the far distance. Therefore, optics, the thing you are comparing it to, is not included, therefore not comparable, Wiggles.
Well, Nathan, with all due respect, what you're getting on with is bullshit.
So you're saying that you can just exclude the very nature of the thing that took those pictures and the workings of those things, optics, when comparing it to an optics exclusive calculation, and you think that's reasonable?
Well, it looks like yeah, so it's a simple geometry problem.
So you've literally gone silent for 2 minutes and then just carried on with your point, ignoring everything I've just said.
I was checking out G. John Gonzalez. He seems like his hangout thing is going now.
Hey, Wiggles, before you leave, or before Nathan ends, I just want to counter one of your points. Can you bring up your picture of the CN Tower again, please?
I can do that. Here it is.
Okay. So part of Nathan's point is if you're not taking in optics and atmospherics into account, into your equations and into the maths and your tests, then you're not taking into account the real world reality and real world scenarios. So everybody can see on the left, there's sort of a blank test, and then what you actually see, right? And it says, why is the bottom missing? So if I can present real fast.
Well, I mean, the bottom is missing because the ocean is in the way, but go ahead.
Okay, so that's the whole that's the whole point of this hour-long conversation with you, is that it's an assumption to say that the bottom is missing because of X when you haven't proven X. Okay, so let me take over and show you a demonstration that we can do and show in real world, based on real world phenomena, based on atmospherics and how we know the atmosphere to work. So I'll share real quick, and then Nathan probably will round out the show, but if he hasn't already. Okay, can you see my screen?
Yeah.
Yeah.
Okay, you see the CN Tower here?
Oh, I saw this before. It was a pretty cool trick.
Yeah, it's really cool because it makes perfect logical sense. So why can I not see the bottom of the rest of the city in the CN Tower? Is it because it's over a curve?
Yeah, so my rebuttal to this actually was, what happens if you lift the camera up higher? Do you then see the bottom of the tower?
That's not the question. Why can't I see? You said you can't see the bottom of the CN Tower because of the water is in the way because of a curve. Why can't I see it in this example? Is this table curved?
No, well, you're refracting the light around.
Oh, you're refracting the light. Now, what would cause refraction in the real world? The atmosphere. So let me hit play and watch as he moves closer to this this lens, which is acting as an atmosphere. Now look at that. As he gets closer, wow, what do you know? You can see more of this tower and the bottom of the buildings. And when he does his blink test, it matches up pretty much perfectly with the one you did.
Yeah, no, I've seen that before. It's a cool trick.
It's not a trick. He took real world observations. Oops, sorry. He took real world observations and knowledge and applied that information, and he performed the test, and that test mimics the real world.
Yeah, but
You
then
took some numbers on a piece of paper and said you proved something. There's a huge difference.
oh, but I want to see like if he's trying to explain that's why the bottom of the building disappears. I want to know if like, well, if you lift up the camera, can you see the whole tower? Because that's what happens in real life.
He didn't assert it. I didn't even hear any words on the video. He demonstrated it visually. Now, clearly, that's an effect that can take place. Now, that would be, let me wonder what the word would be. Oh, yeah, an optical effect. Now, you've made it clear there are no optical considerations in your geometric-only calculator. So it's a false equivalence, one where you ignore perspective and ignore optical effects, and then call the effects that actually take place on your optical-based pictures curvature. They're not. They're optical effects. The very thing you ignore and say isn't necessary.
Well, what I was doing, I was just solving a basic geometry problem, but it seems like people don't understand what that means when I say that, so I was going to go through a basic geometry problem just so people are familiar with that then.
We understand geometry, but what we're saying that you're not getting is geometry isn't the only thing you have to take into account. Do you understand that?
Well, I don't like.
Do you understand that geometry on a piece of paper is not the only thing you have to take into account in the real world?
Well, I would think that it's pretty obvious when you can to tell when one object is obstructing another object. I think that's like pretty obvious.
What, like in Chris's demonstration that we've just seen? Yeah, Wiggles will never concede that only using his optical, exclusive, geometry-only calculator will only ever result in him begging the question. He'll never ever get it because he's a fundamentalist, globe-head religious zealot. And with that, I'll say if you're watching this on Nathan Oakley 1980 channel, then stay tuned, as there will be an after show to follow. However, if you're watching this live on the Nathan Oakley channel, unfortunately, this is where we bid you farewell. A massive, huge, enormous thank you to all who tuned in, smashed the super chat, shared, liked, subscribed, all that good stuff. Also, a massive thank you to all of today's live panel for making today's debate possible. I've been Nathan Oakley. Be sure to check out the nathanoakley.com Flat Earth Debate Forum. I'll see you all in the next video.
Oh, what a day! What a lovely day!
Can demonstrate that exact same phenomenon, and now you're changing the goalpost and saying, well, oh, what happens if you lift it, though? We're not talking about what happens if you lift it. We're talking about what you showed and what I countered.
Yeah, but if this explanation is if really the Earth is flat and it's this optical phenomenon is why the objects are disappearing, then or being obstructed,
Right,
then
it's
I would
not a
want to know.
supposition.
Well,
God,
okay, well, if this explanation is true,
Wiggles,
then
Wiggles,
when the camera
Wiggles,
gets lifted
Wiggles,
up,
Wiggles,
you
it's
should
not a
see the bottom of
supposition.
the object.
Wiggles, it's not a supposition. It's not an if statement on paper. It's a demonstration of optical effects. So he's not supposing that maybe if we change the camera, we'll see the bottom reappear. It's a optical demonstration of exactly that happening. And that does happen. It's not a presupposition made by a fundy, you. It's an actual demonstration of it actually occurring. So while you might say in your actual demonstration, rather than presupposition, you could lift the camera, well, we didn't say that to you when you presented your blink test. Well, if you just lifted the camera, he'd get above the waves that's obscuring it due to perspective. We just said, no, where's the optical account in your mathematics? And there isn't one. because basically all your mathematics do is call optical effects curvature. So all optical effects are removed, and all you're left with is an assertion of Earth curve. So suddenly, when you believe you're on a sphere, there's no optical effects anymore, which is nonsense.
Can I make a quick comment?
Well, yeah, well, I'm probably going to leave very shortly now, but I just want to ask you, Chris, do you know what happens, like in Rob Skiba's demonstration, when he lifts the camera up? Has he done that?
Hey, Wiggles, real quick before.
No,
Chris,
I'm asking Chris, though.
I know, but you're red herring.
Yeah, total red herring.
Right now.
Yeah, we wouldn't get away with doing that on your blink test, would we? Would we? All that would happen if we did that on Wiggles' blink test is Wiggles would assert that you've got above the Earth curve. Absolutely nothing to do with lifting the camera, just getting above Earth curve, because the optics would be ignored, and it would just be the Earth curve that would be the reason why we could see and we couldn't before. No optics. So raising the camera, nothing to do with optics, just Earth curve obstruction being reduced.
So we don't. So do we or do we not know what happens when Rob Skiba lifts up his camera in his demonstration there?
What is demonstration of optics affecting the bottom of things being visible? Yeah, optics affect the bottom of things being visible, you red herring using asshole. Yeah, they are absolutely in effect when you use a camera and completely ignored from your calculation. Are you going to address that, or just keep asking if Rob Skiba raised his camera?
Well, Rob Skiba didn't raise his camera.
Oh, you are just going to stick with this red herring indefinitely, asshole. Yeah, your maths doesn't include this effect, Wiggles. Why not?
Like, if Rob Skiba raises his camera and then the bottom of the...
Your maths doesn't include this effect that you're now arguing about. So who cares? It's not included in your maths.
I'm not even talking about my maths. I'm talking...
Yeah, we are. We're talking about your maths. And the fact it doesn't include this effect. It's not included. The only effect that's ever used as the cause is Earth curve, excluding all optics. It's geometric only. But what are you comparing the geometric only, non-optic maths with? Well, you're comparing them with pictures.
All I'm trying to say is if Rob Skiba lifts up his camera...
Yeah, you just want to use your bloody red herring indefinitely. And I'm tired of it. You're not addressing us. We're saying this effect that you're now arguing about, the raising and lowering of the camera, that if it was your picture that we were using this argument with, you'd blame on Earth curve, excluding all optics. This very effect that you're now detailing is not included in your calculation.
Because light, for the most part, travels in straight lines.
Oh, really? So we don't observe perspective. It's just fucking Muppet vision only. Straight lines, no, my friend. These lines on screen converge at the centre. They're not straight. They're converging at a midpoint. That's called perspective. Same in your pictures. They also converge. Not straight, converging perspective lines. Excluded in your geometry calculator.
Muppet vision is the same drawing technique that engineers use to design parts.
And is that what we're looking at now on screen? Are we looking at this picture of mountains in Muppet vision, otherwise known as orthographic view? Is this an orthographic view, or is this an optical representation of reality? Not a schematic. This is a picture, like the ones you had up, Wiggles.
Schematics are useful for what
Is
we're doing
this
here.
a schematic?
Well, that's not, but...
Right, were your pictures that you compared to your schematic mathematics, were they schematics, the one with the blink test?
Well,
No, they weren't, Wiggles. They were optical in nature, unlike your calculator.
Hey, Wiggles, can I ask you a question? You made a
sure.
statement. You made a statement that all light travels in a straight line. Is that right?
For the most part, yeah.
Okay, I just got a video I just dropped in the side chat that shows that that's not true.
I know it's not true.
But you just said it. You just said that light always travels in a straight line.
I said, this caveat, it mostly travels in straight lines.
Okay.
Yeah, I know it bends a little bit, but it mostly travels in straight lines.
Okay.
So why does it bend a little bit? What causes the bending?
Refraction.
Okay, what causes refraction in the atmosphere?
Well, I mean, you could ask it. In science, like what we do is just kind of observe something happening. We define quantities and just.
I'd just answer for him because he's a dick. He doesn't have any of those accounted for in his mathematics. He only has the begging the question presupposition of an R value and 7/6 attributed to it, because he in his mathematics will use something called terrestrial refraction. He will not use anything to do with the actual conditions. He will just use the presupposition that Earth has a radius value, R, and then he'll flatten it out with 7/6R. Terrestrial refraction, an arbitrary begging the question on steroids applied to his already presupposed sphere.
Well, I thank you for your time, Nathan, but I think I'm just going to go. I think this is unproductive.
Yeah, because you're a fundy zealot who never ever concedes anything ever. So you've reified a model, you've used geometry where we're comparing to optics, you've not conceded that you're fallacious in your begging the question assertions. So yeah, I'd sod off too if I'd lost as badly as you had, Wiggles.